Greetings, Algebra 1 class. This is the first video, and in it I will be doing a few of the examples that you requested that we go through together that were on your homework, which we will be finishing up when you come back to class on Monday. So I'm going to do the ones you requested, plus a few extra, just in case you would like to see them. Those are numbers 10, 36, 54, 56, 59, 61, and 66. So some of the more complicated problems as well as a couple of easy ones. I'm going to begin by folding the paper in half just so that I can do the work on the left-hand side and then make any additional notes about side concepts you may want to know about on the right-hand side. So beginning with problem number 10. Problem number 10 says that we need to evaluate the expression if, and I'll put the extra information here, A equals 4, B equals 6, and C equals 8. This one isn't too bad, especially in terms of the time it requires. So we're going to just do 8B minus A, quickly rewrite it, and then I'll begin by substituting in the different letters. So I'm going to quickly copy down 8 times B is 6 minus 4 for A. If I follow the order of operations, that gives me 8 times 6 is 48, right? Because 8 times 5 is 40, that would be 48. So 48, and then minus 4, subtraction comes last. And that gives us an answer of 44. And so here I've written out my note neatly and put a box around the answer. If you could do that when you turn this in, that'd be great. Now, number 36. I had a few questions about that one. Now, in problem number 36, it asks us to write an algebraic expression to represent the area of a triangle. Then evaluate it to find the area when height equals 12 inches. I'll rewrite that problem, or at least a little bit of the information we need to know, out to the side. Sometimes that's helpful to have when you're looking at your paper. It says the height of the triangle is h, and the base of the triangle is equal to h plus 6. Let me move that around for you guys. Now, we just need to find the area first. There's two steps to this one. Find the area and then evaluate it. So I'm going to rewrite my formula for the area of a triangle to start out with. Many of you may know that is equal to 1/2 times the base times the height. Well, I can plug in the base. Now, the base is going to be equal to h plus 6. Let's write that out in our side notes just so everybody can see it clearly. B equals h plus 6, and then the height is just h, so we'll plug that in again. So this is going to equal 1/2 times, and I'll put that in parentheses because it goes together. It's all equal to b, h plus 6, times h again. Now, the tricky thing about this problem is that we have to determine what to do next. We could distribute, but let's try the order of operations again because that is what we're practicing right now. So I'll write my 1/2. And then, well, h plus 6, that's a little tricky. There's not a way to simplify the expression in parentheses. So when we can't do that, we're going to have to use the distributive property. But let's check whether we've actually done what it's asking for the first part. Now the first part just says, write an algebraic expression to represent the area. Well, an algebraic expression is just a math phrase. Have we written a math phrase? Well, yes, actually we have. So we've already solved the first part of that problem. This is the expression that represents the area. Now, the second step was to evaluate the expression. I'm going to write that down, evaluate. This is the one that means find the final answer, the numerical answer. So to evaluate it, we're going to plug in to find the area when h equals 12. So I'm going to write that down right here. H equals 12. Now, let's try plugging that in. This is now 1/2 times 12 plus 6 times h again, which is 12. Now it's much easier. We don't have to distribute. We can again use the order of operations. So that'll be 1/2 again times, in parentheses, we're going to get an 18 there, times 12. Now we just get to go in order. Now here's an example of when you have parentheses where you don't need them. I kind of left them there because they were there before. It reminds me that this is equal to that. But it's just a little extra stuff. Having parentheses around a number when it's by itself doesn't actually mean anything. So here we have 1/2 times 18 as our next step. That's going to give us 9. We can multiply by 12. And when we do, we get, and you can use a calculator for this if you'd like, 108. Now, the answer isn't really complete unless we have our units. I would be deducting points if you don't have units in your homework. So I'm going to write h equals 12 inches. That's really important. Now, how many h's appear in our expression? There are 2 of them, which means that if we're multiplying something that's inches by something that's inches, that should give us inches squared. So I'm going to write square inches as our units for this area. And put around a box to indicate that this is in fact my final answer. And now we are done with problem number 36. Let's try problem number 54 now. In problem number 54, it just asks us, once again, let's change our focus a little bit. There's the problems that I'm doing on the bottom. In problem number 54, it says to evaluate, once again, the expressions if a equals 8, b equals 4, and c equals 16. Let's rewrite the expression in problem number 54. This one's a bit complicated. It's 2a minus b squared over ab plus c minus a over b squared. That's it. Now, let's look at it before we plug in the numbers and see if we can simplify anything. Ordinarily, we would evaluate exponents first, and then, well, first parentheses, actually, because we are using PEMDAS. Please excuse my dear Aunt Sally. Now, you can think of anything on the top or bottom of a fraction as being in parentheses. Unfortunately, because these variables are not the same, we can't actually simplify it. And we would really want to simplify it before we can divide by anything. It doesn't look like there's anything we can divide by here. We can't cancel anything out. That means we're going to have to plug in our numbers. So let's try that. When I plug in, I get 2 times 8 minus 4 squared over, and a times b is going to be 8 times 4. We can add in the other fraction, which gives us 16 minus 8, again, over b squared, which is 4 squared. Now, we might be able to do a few steps at once because they don't really interfere with each other. As long as the values don't affect one another, we can do multiple simplifying steps at once. And I'll walk you through it on the video so you can see exactly what steps I'm doing first. So within parentheses, I'm going to simplify the exponent, and I'm going to simplify this multiplication step because those values don't affect each other. So 2 times 8 is going to be 16 minus 4 squared, which is also 16, yikes, divided by 8 times 4, which is 32, double 16. In this one, we've got 16 minus 8, which is 8, divided by 16. Well, yikes. In this one, we have in parentheses 16 minus 16. That's a problem. It gives us 0. Now, if that were in the denominator, we couldn't do anything. We would get an error as our answer because you cannot divide by 0. However, it's perfectly fine to have a 0 on top, and when you do, it's just going to simplify to a 0. So this is going to come out equal to, let's see what this comes to, 8/16. That's the same thing as 1/2 if I simplify, and this is the same thing as 0, because when you divide 0 by anything, you get 0, which means our final answer is 1/2. And I'll put a box around it and some equal signs here just so you can see all these expressions are equal to one another. Now, the next problem we wanted to solve was problem number 56. So we're going to turn the page here. We'll keep in mind which ones we wanted to do. I said we'd be doing 56, 59, and coming up after that, you'll see from number 61 and 66. So let's try those out. Now, in problem number 56, we are told to, need to turn the textbook page, one moment. And we're just going to split up that video file so that they're a little bit shorter each. Now, we're going to do our next 4 problems together. Problem number 56. In problem number 56, Evelina is shopping for back-to-school clothes. And it actually gives us a chart telling us what all of the clothing is worth. So let's write that down. I'm going to do that on the other side where I put my additional information. Skirts are worth $25.99 each. And jeans, we'll need to use that value also, are $39.99. Dang, she shops at really expensive stores. Sweaters are worth $22.99. Well, I guess it's just the jeans that are expensive. Let's make sure also we know what it's asking us to do. It just says evaluate an expression. Those are the keywords to find out how much money she spent on clothes with including sales, or without including the sales tax. So if we need to evaluate an expression, that means we have to write an expression first. So let's figure out what that expression is going to be. It says she has 3 skirts. Let's assign us some variables. S can be, well, skirts and sweaters. We'll make S equal to skirts, J equal to jeans, and sweaters, I'm going to put a W, our second letter. So if she bought 3 skirts, that would be 3S, plus 2 pairs of jeans, that would be 2J, plus 4 sweaters, that would be plus 4W. Now we have an expression, and we just have to evaluate it. To evaluate, we're going to get that this is equal to 3 times $25.99 plus 2 times $39.99 plus 4 times $22.99. So not only have we written an expression and plugged in the numbers, we have to evaluate it now. You're going to want to do this one on a calculator, which is perfectly fine on the homework. Now, it comes out to $249 when I plug it in, and 91 cents. That should be what you get as your final answer. If not, you may want to check that you entered everything in correctly on your calculator. Let's try problem number 59 together now. Problem number 59 is a find the error type of problem. it says that Tara and Curtis are simplifying the following expression. I'll put our additional information over here. 4 times 10 minus 3 squared plus 6 times 4. It wants to know, is either of them correct? And we must explain our reasoning. Well, one way of determining whether or not they're correct is just to do the problem ourselves and figure out whether they're doing it the same way as we are. So I'm going to rewrite the expression, and we can try to solve it together. So I'm going to put it right over here. 4 times 10 minus 3 squared plus 6 to the 4th. Now, in this one you have parentheses and then you have brackets. This is just an example of a different type of notation you'll see. If you see a parenthesis that looks like this, or a bracket that looks like that, that means the same thing as a parenthesis sign. They're really exactly the same. The only reason they write it differently is because when there's a bracket, it's kind of telling you that there's another set of parentheses inside that you should look for. It's like, hey, there's going to be another set of parentheses inside of me, so don't forget that it's there. It just tells you how many nested parentheses you have. Sometimes they don't use it, sometimes they just write parentheses instead. And either way is okay, your choice. Now, let's try simplifying inside the parentheses. To simplify this, I'll do 3 squared, and then that's not affecting the value of 4 times 10, so I'll do those at the same time. That gives me, and check it out, I switched what my parentheses look like, no problems there. 4 times 10 is 40, then minus 3 squared would be minus 9. And then plus 6 times 4 is, well, that's plus 24. So that comes out to, well, before we figure out what it comes out to, let's check what Tara and Curtis did. Well, we can finish it up real fast to see which one is the final answer. That should tell us who got it wrong. Now, 40 minus 9 is 31. We add 24. We get, I'll add each digit, 55. So we know that the answer is 55, and in the book, if we look at Curtis's work, Curtis is the one who got 55. So we should be looking and thinking that Curtis is the one who got it right. Now, it says, is either of them correct? Explain your reasoning. So I'm going to start out by writing part of our answer and saying, yes, Curtis is correct. We could write down, if we wanted to, he got the right answer. But before we stop there, let's take a moment to figure out what Tara did wrong. I'm going to rewrite Tara's work over here on the other side where we keep our additional information. Now, Tara did 4 times 10 minus 9 plus 6 times 4. That is okay. She rewrote the expression just like it was, but then somehow she simplified to get 4 times 1 plus 6 times 4. It looks like what Tara did was to take that 10 minus 9. She actually did that first. So the problem is that Tara subtracted before she multiplied, and that's what gave her the wrong answer. So let's write that down too. That's part of giving a nice detailed answer that clearly explains our reasoning. I'm going to write down that Tara didn't follow the order of operations. She subtracted 10 minus 9 before multiplying 4 times 10. And now that is an extremely detailed answer on which you couldn't possibly go wrong. Full credit, plus plus, work displayed on the work wall. So let's go on to problem number 61. Remember, you can always meet me before or after class, or even make a comment on this video if you'd like more explanation on one of the topics we covered. We're going to do, I wrote 66, but we're going to do 61 now. 61. And 61, oh, it says challenge. It's going to be a challenge problem. Write an expression using the whole numbers 1 to 5, using all 5 digits, and addition and or subtraction to create a numeric expression with a value of 3. So let's write out our additional information right here. We have to use this check using the whole numbers 1 to 5. So we have to use 1, 2, 3, 4, and 5, and get a value of 3. Now, I think the tricky part for this problem is figuring out how to start it. So we don't really know what order to go in, that kind of thing. So I'll tell you my thought process as I'm working through it. Now, we have something, something, something equals 3. Well, I'll just write down my notes as I go along. I know that 3 equals 3, so if I just had that number there, that would be fine. I know that 4 minus 1 equals 3 also, and I know that 5 minus 2 is another way to make 3. So actually, I've made 3 times using all of my numbers. If I added all of these different expressions together, I'd come out with 9, which is not what I want to do, but I'll show you what I'm talking about. If I did 3 plus 4 minus 1 plus 5 minus 2, I'd come out with 9, because that's 3, and that's 3. But I bet that I could get some of these expressions to cancel out with each other. What if I took this expression, 4 minus 1, and then I subtracted 5 minus 2? Well, I know that, I'm going to write it over here, 3 minus 3 equals 0. So if I have 3 plus 0, that's 3. Basically what I want to do is do 3 plus 3 minus 3. Do you see where I'm going here? 3 plus 3 minus 3 has to be 3. I know I would get 3 as my answer. And I know that I could do that if I change that addition sign to a subtraction sign. Let's write it out and see how it turns out. I can do 3 plus 4 minus 1 minus 5 minus 2. That's one way to do it. So that would give me 3 plus 3 minus 3. Well, we've already decided that 3 plus 3 minus 3 is going to be whether or not there are parentheses here, because it doesn't change the order in this case. 3 plus 3 minus 3 is going to be 6 minus 3 equals 3. So we know that we have an expression that gets us the right answer. Now, just so you know, that is actually the strategy that I use and the way that I think about it. In case you're wondering, I can show you what is in the teacher edition of the textbook. Now, teacher editions don't show any work, but it's giving us the recommendation that we write 5 plus 4 minus 3 minus 2 minus 1. If you were thinking more along those lines, basically what you would end up doing is, you know that 5 plus 4 is 9, 9 minus 3 is 6, you can subtract another 2 and another 1 to get 3. So that's also an acceptable answer. There are a lot of ways to do this, but I like to play around with my numbers and break problems down into smaller pieces, and that is usually what helps me when I have a problem that I don't know how to solve. So any way is okay on this one, and we can talk more about problem-solving strategies if you'd like in the following videos. So let's move on for the time being, though, to problem number 66. This is our last problem that we'll be doing together. And I'm going to, again, fold the paper over so that you can see what is my relevant problem information, the work as it would be nice if you show it and you do your homework, versus the additional information that you're looking at as you're doing your sketch work. Problem 66 is one of our standardized test practice problems. It really just wants us to simplify the expression, and I'll write it here. So simplify. Yikes, this is a long one. 10 plus 15 times 2 cubed, again you see those brackets, really just means there's a parenthesis inside, divided by another bracket, 7 times 2 squared minus 2. Here you can see that they're using a parentheses as like a multiplication sign. That's okay to do also. And it gives us some steps for solving it. It says what is the first incorrect step. So we have to identify the incorrect part, and then we have to explain. This is another one of those explain your answer type of problems. So let's start out. And then as we're solving it on our own, what we can do is check with what the book has and figure out where did they go wrong. So I'm going to rewrite the first part of our equation once more. 10 plus 15 times 2 cubed divided by 7 times 2 squared minus 2. Now we can check, and it looks like they've written it down correctly. Step 1, well, we'll solve a little piece of it first and figure out what they did. So I'll start inside the parentheses, and then from inside the parentheses do my exponents first. So that'll give me, and I'm arbitrarily changing what the parentheses look like, once again, that'll give me 10 plus 15 times 2 cubed is 9. So 15 times 9. Divided by, once I evaluate this exponent, I can just use regular parentheses here. That'll be 7 times 4 minus 2. Now, let's check out what the book did. It's saying that for step 1, they did 10 plus 15. Oh, sorry, I wrote this number wrong. 2 cubed, not 9. This is, I was thinking 3 squared, but 2 times 2 equals 4. Times 2 again is going to be 8. So we're going to change that 9 to an 8. And there we go. Happens sometimes. So they got 10 plus 15 times 8. And then after that they divided 7 times 4 minus 2. So in that case our steps actually do match up. Let's use our own knowledge of order of operations to find our next step. After that, we would do 10 plus, what's 15 times 8? Well, that's going to be the same thing as I can half one number and double the other. So I know that 15 times 8 is the same thing as 4 times 30. That's easy to figure out the answer to, even if I don't know 15 times 8, because 4 times 30 is going to be 120, 12 with an extra 0 on the end. So just illustrating that for you, we could have done that in our heads too. It's going to be 10 plus 120 divided by 7 times 4 minus 2. Well, 7 times 4 is 28 minus 2. That is okay. And actually, if we look at the book once more, they give the exact same step. They wrote down 10 plus 120 divided by 28 minus 2. Okay. Well, let's try the next piece. It looks like they're okay up through step 2. If we do step 3, that'll be 130 divided by, I'm evaluating inside each parentheses, 26. That matches their step 3 exactly. Now we just have to do 130 divided by 26. Well, I'm thinking that that should fit, 25 fits into 24 times, and it fits into 125 5 times. So let me just see if 5 works. 5 times 6 is going to be equal to 30. Carry the 3. 5 times 2, 10, plus 3 is 13. And in fact, that gives us an answer of 5. Now, let's check what they got. That does not match their step 4. They told us that, according to the book, 130 divided by 26 is going to be equal to 1/5, which is clearly wrong. So when we want to answer this question and explain our answer, we're going to say that step 4 is the first incorrect answer. And when we explain our error, we can just say 130 divided by 26 is 5, not 1/5. And that would be a very clearly explained answer. So that might be how I would go through it. I like to do my math work slowly and thoroughly, which is useful for making videos. But some of you might find faster tricks, and I would love to hear in comments ways that you did that math problem even faster than I just did. So that is it for our intro homework video. Thanks.